Welcome back, everyone. I'm John Furrier, host of theCUBE, here in our NYSE CUBE studios on the East Coast, the access point on the hub of New York City. It's the key to innovation here on the East Coast. Of course, the Palo Alto studio is in Palo Alto, connecting Wall Street and Silicon Valley. We've got a mixture of experts here. We got another expert coming in, CUBE alumni, Donny Greenberg, who's the CEO and co-founder of Runhouse, doing some amazing things with machine learning, open source, Kubernetes. Donny, great to see you again. Last time I saw you, we were here in December, the NYSE. We were riffing around enterprise AI, a lot of cool stuff. Thanks for coming back on.
Yeah, thanks for having me. Great to see you.
So I know you got some big news going on, so let's get into first the update of what's happened this past year in your side. Obviously, you guys had the machine learning piece going on strong. You were pioneering these infrastructure solutions. What's the update? Give us what's happened since we last talked.
Yeah, since we last spoke, the big news is that we are announcing a brand new product line today, which is called PyTorch. And since we last spoke, the big news is basically the broader move across enterprise, frontier AI labs, startups, everybody towards Kubernetes for ML. And that really, there are a number of drivers behind that. But we basically saw that move. Saw the gaps in the ecosystem around ML development on Kubernetes, and then today are addressing those gaps with a new development system which doesn't throw away all the amazing things about Kubernetes, but rather takes advantage of them, but unlocks a lot of the modern ML workloads that enterprises and frontier labs are trying to run on Kubernetes, in particular reinforcement learning and post-training and agentic training.
Well, we got KubeCon North America coming up, so obviously there'll be a big narrative going on there. What's the problem that you solved? What was specifically, because cloud native is booming. Kubernetes is really kicking ass as a key centerpiece for that DevSecOps piece. But again, that's old cloud native world. That's not necessarily AI native. Can you just connect the dots for us? What's the relevance between Kubernetes and the AI native workflows? And where specifically is the linkages?
Yeah, it's interesting. Kubernetes has been used in ML for a long time, but it hasn't been, there have always been significant gaps, and it hasn't been the de facto solution for certain things in ML. So Kubernetes was primarily built around a development to production workflow, which assumes that you can build and iterate and debug your workflow or your program locally on like a dev box or a laptop or wherever you do your fast development. And then you package and deploy it to Kubernetes, or Kubernetes handles things like auto-scaling and observability and things like that. In ML, there is no local dev. It just doesn't exist. I unfortunately don't have the GPUs or the distributed compute that I need attached to my laptop. And so I have to be doing my iteration and development directly on Kubernetes. And that has never been supported by Kubernetes. It wasn't fundamentally built into Kubernetes before. Kubernetes always supported inference workloads pretty well. Recently, it's gotten much more complicated because you have composite inference workflows, like RAG is the very, classic example, yeah. But practically any serious ML application out in production today is some sort of waterfall of multiple calls into multiple models. And those also are not runnable in an isolated way, right? You don't have a single machine dev experience for running a composite application that has this type of model running as an auto-scaling service, and then this type of embedding model running as an auto-scaling service. So it's distributed and composite are the places where Kubernetes just has never had a dev experience. Historically, frontier labs didn't rely on Kubernetes for these things. They relied on Slurm, for example, for large-scale distributed training. Reinforcement learning does not fit into Slurm. You cannot do heterogeneous orchestration of these kind of multi-component workflows in a system like Slurm or like even Kubeflow and Kubernetes. The simplest way to explain it is that the modern battleground for ML is post-training. These frontier labs are competing with each other in reinforcement learning. And reinforcement learning is this dizzying interplay of training and inference and data processing and evaluations. And you just can't take a SageMaker training and a SageMaker inference and a SageMaker data processing job and say, okay, launch, and then have it do reinforcement learning. You need to be able to orchestrate in much, much more detail, and you need to be able to interactively develop and debug that. So that's what we do for Kubernetes. It's never really been possible before.
I love that little description. I want to just unpack that if you don't mind, because you mentioned SageMaker. We saw Amazon separate Bedrock and SageMaker. Maybe SageMaker is more under the hood. Obviously, there's some knobs and buttons to turn there. for Amazon, but not everything's on Amazon. You also mentioned some of the machine learning requirements you need to have a deep learning framework in production workflows. So obviously the name KubeTorch, PyTorch comes to mind. You have pedigree there, both on the project and at Meta. What is it about the PyTorch Kubernetes intersection? Is that related? I mean, obviously PyTorch frameworks built by Facebook AI, then it kind of Linux Foundation took it over. So is there a connection there, and what specifically, how should I look at that?
Yeah, the reason we named it that way is in analogy with PyTorch is to TensorFlow as KubeTorch is to Kubeflow. Kubeflow was a way to be able to do ML on Kubernetes that brought the ML people to Kubernetes but didn't bring Kubernetes people to ML. In the same way that TensorFlow requires you to use a very linguistically restrictive DSL to be able to program with your GPUs, and it's really not debuggable because you just sort of submit your workload into the GPUs and then whatever breaks. PyTorch inverts that structure by giving you this extremely fast programmatic interface to wield and orchestrate on your GPUs. And we do the same thing for Kubernetes. So rather than bring the ML, bring the job to the compute on Kubernetes, we actually bring the compute to the workload in a sense. And what that means is that we can very aggressively freeze it in place for extremely fast development. So for comparison, if you're developing on Kubeflow, every time you add a print statement into your code to debug something, you're going to basically rebuild Docker images and resubmit to Kubernetes, which is then going to basically reload your entire application, load down data, load down models, etc. It's about a 20 to 40 minute iteration loop for most teams. And because our structure inverts this and we freeze the resources in place while you iterate, our iteration loop is about 1 to 3 seconds, right? So that's really a 600x or so improvement. And the linguistic control where you can program and orchestrate these complex workloads in Python, that's also unlocking what PyTorch does as far as giving you the full power and control of Python when you program with GPUs and instead of this narrow subset. And that's why it's KubeTorch is so powerful for RL. So you're reading the analogy correctly, basically.
All right, so KubeTorch, what's the core news? Break it down. Why, when, how, what's going to happen? What's the progress? Is it a new project? Is it code base? What is specifically we talking about here?
Yeah, so specifically, we have spent the last several quarters maturing the product with a private set, a kind of a private alpha set. And today, public companies, frontier labs, AI native startups are running thousands of workloads on KubeTorch, and they're experiencing all the types of big transformative success with their ML development that we wanted to measure out of the system, right? That 100x faster iteration or 95% lower time spent babysitting and resolving infrastructure failures. Those were the reason that we fundamentally built the system, and we've observed them in practice. And now we're basically expanding out to the next set of essentially a beta group. So that's what we're announcing today, that basically KubeTorch is now in beta for people to use. It installs directly on your own Kubernetes cluster, so you don't need to migrate to a special cloud or out of your existing cloud setup. It takes generally 30 minutes to install and get up and running and be able to run distributed workloads. We're hoping to also have some news later this year, more in the open source department. But for now, we're just keeping everything closed beta as we mature and scale the system.
So closed beta.
Well, it's an open beta.
Open beta. Okay.
Previously it was closed, and now it's an open beta.
Got it. Okay, cool. Just want to make sure I clarify that because that's awesome. You'll learn too. You'll see what comes out of it. So I want to go back to the alpha curation. I mean, take me through that. It's where are all these people hanging out? Are you on a Slack channel? Is it a WhatsApp thread? Is it friends of yours? Hey, because you nailed the problem. You had good working data. Take me through some of the mechanics of those use cases because it sounds like you did the work to harden it up. There's just how do you find someone with those problems? Are they your friends? There's no message boards, but Slack channels. And where do you get this? Where do you get those guys?
It's a really funny problem in really hardcore infra. Yeah. explain the exciting parts of what you do to like, your friends and family.
Yeah.
And they don't like ripple through the broader sort of like human interest article, like startup articles.
Yeah.
Like one of the most exciting things that we can do that's just like absolutely groundbreaking is called dynamic world resizing of training jobs. Like basically it has never before really been possible to take a training job and dynamically resize it as it executes. So it could be running with 2 nodes of GPUs today and then say, oh, actually, I want it to be 100 nodes. And the reason why this is extremely groundbreaking is now you can always max out your cluster utilization. Like you can, as jobs finish, you can claim their capacity and a new priority comes in, or like inference scales up because you're getting more usage, you can scale down the training jobs. That's crazy and it's very difficult to do. No one I talk to, especially not like, senior people at big companies, cares about that. You need to find like very, very specific opinionated people who care about these problems that we're solving. And the truth is that like, if somebody has this problem, they know that they do. And we do a lot of content marketing and we do a lot of like, we have a really strong AI network, from Meta and from just like, the New York AI community. And we've found these people pretty dependably. And as soon as we do,
word gets out. Word gets out fast. The bat signal goes up, like, because everyone's struggling with the same problem. They're banging their head against the wall. And to your point, I asked the question because I wanted to get that out there because this is an exciting systems play, right? It's not like obvious, to your point. And so word gets out fast. What's been the reaction from some of the hardcore distributed system thinkers?
Yeah, it's interesting. The infra world is extremely conservative. Like, when we talk to like large enterprises, they're basically evaluating us as their next paved path to like ML development, coming from maybe a major SageMaker move that they did in like 2018, 2019 or something like that. And so they know that even if they're looking at this product and it does what they want it to do, they need to do a tremendous amount of substantiation of the system to avoid getting any kind of real backlash. And so usually it's like we're put through the ringer. Like recently when we were onboarding a customer, I had to like demonstrate to them that we could like basically sustain our execution latency up to like thousands of nodes. And this is a customer that like wasn't using thousands of nodes. They were using like a very small number of nodes per workload, but they just want to know because if they're going to make a big investment, if they're going to, migrate their ML infrastructure to the system, it has to be able to accommodate both the next 2 to 3 years of like actual methods innovation, like be able to do reinforcement learning and post-training and all that kind of stuff. And it needs to be able to scale in case they just like hockey stick scale their models. So usually the reaction is like, this is incredible, but I need to see it in action. And then, there's some number of people that are so desperate for solutions here that they just like sink their teeth right into it. And actually our typical POC, just to give you a sense of how demanding these customers are, our typical POC includes running in production before we're even getting paid, right? So like a company is using us basically to migrate full training and inference workloads to production to evaluate the full end-to-end. And then they're like, okay, this is going to be like, my infrastructure bet that I'm willing to make. So that
I got a couple of sales guys who will help you get paid on those POCs. They should be ponying up. I wanted to bring that up because the Kubernetes, the SageMaker comment is interesting because it come up multiple times on our series this here. Because what Amazon did is they decoupled Bedrock from SageMaker, mainly because the alphas were at SageMaker level. But it points to what you're doing. At that layer, it's hardcore infrastructure. And you're enabling the dev on top, and in the middle is whatever the action is. So that's a trend we're seeing. What's your reaction to that? Where does that? I'm using SageMaker generically as a horizontal position. What's your reaction to that?
I think it's a perfect representation of a trend that we're seeing in the broader ecosystem, which is a distinction between companies that are AI consumers and companies that are AI doers. And that distinction is driven by a realization, as I mentioned, the battleground in ML today is post-training, at least between the frontier labs. So the people who are producing like, your OpenAIs, Anthropics, et cetera, they are spending through the nose to buy high-skill data sets to be able to post-train their models, to adapt them for high-value agentic workflows in enterprise. And at the same time, so they're paying like a private equity analyst to produce a financial model that they can use as ground truth, one of many, pieces of ground truth data to adapt their model to make it good at finance. But guess what? Every bank and every private equity company is passively producing thousands or millions of those models, right? And these companies are realizing it, and they're realizing, oh, well, I'm waiting for a Frontier Labs models to get good enough at my agentic workflow. I'm actually sitting on this like ludicrously valuable data estate that could be used to actually produce that model and like
sell it back to Anthropic too. Yeah, I mean, yeah. So yeah, the tail wags the dog, as they say. In this case,
so the distinction between Bedrock and SageMaker is actually like, I think a broader distinction which is forming. We're seeing enterprises self-select. Are they going to use models off the shelf? Are there use cases covered well enough by essentially the LLMs from Frontier Labs, which plenty of them are? Or are they saying, actually, I'm going to self-select as somebody who wants to who sees my data as the crown jewels of what I have as a business or as like a technology business, and I want to mobilize that into my own models. And we've seen like crazy case studies from Netflix, Stripe, and Nubank, the absurd business results that come out of like scaling compute and data when it comes to building like first-party foundational models. Yeah. And we're also seeing that the RL methods are now really robust and really stable, and they even work at relatively small scale, that like lots and lots of companies are starting to actually want to use this tooling. And then they're realizing, oh, my infrastructure hasn't kept up. I can't use the infrastructure that I put into place in 2018. I need something modern that actually can like do RL, and that's basically the big push that we're seeing.
Donny, great chat. I wish I had more time. Certainly we'll get you back. Congratulations on the news. And obviously we'll be following this. This will be going to be an amazing lead into KubeCon North America and ongoing enterprise AI adoption as the stacks start to figure out where their assets are. And we always say the data moats are key on the enterprise. So really appreciate you taking the time. Good to see you again.
Yeah, appreciate you being here. I hope to see you at KubeCon. Hopefully there's going to be a lot of discussion.
We'll see you before. I think we'll hit you up before then. Keep cranking away.
All right. Thanks a lot.
I'm John Furrier. We are here at theCUBE's NYSE studio for the NYSE Wired program and the Wired community with theCUBE. CUBE Wired, NYSE Wired, all working together to bring you all the open data to share that. We have tons of source data to train those models on. Stay with us more. Thanks for watching.